This is one of my favorite topics in the course, food, agriculture, and I'm deeply interested in everybody's personal connection to food. You are what you eat, you are what you breathe, you are what you drink, and we often don't have a very good understanding of what's in our food, what's in our air, and what's in our water. So hopefully this will sensitize you to that problem. And also to get you to understand, hopefully, the structure of U.S. environmental law that applies to food and agriculture. And this is an interesting area of law. Food, like plastics, like energy, it really does not have a distinctive, specific body of law that applies to it, as opposed to air and water or pesticides. So that's kind of curious. It's a problem that cuts across many different areas, many different types of regulation, and the management of food in the U.S. and the management of agriculture is really fractured among a number of agencies. Great Britain recently centralized their regulatory program and created a single agency to manage food. And we'll think about the wisdom of doing that and some of the strengths and weaknesses of the European and British system. So to begin, I want you to think about the percentage of the world that is used to grow crops or to graze livestock. So there are 30 billion acres of land in the world, and about 4 billion acres of those are in cropland. So roughly about 1/7 or 1/8 of the world is used to grow crops. Within the United States, it's about 400 million acres of land. It's an enormous area. And it's dispersed increasingly in more remote areas as cities grow, as suburbs sprawl, and as farmers are pushed further and further away. And this has really interesting and important implications for environmental quality and also for human health. So here are 4 crops represented in these pictures. Wheat in the upper left, corn. Many of you probably are unaware that on a daily basis, most of us consume cotton and a variety of foods without recognizing it. Anybody know in what form? Oil, cottonseed oil. It's part of many pastries, many different kinds of cereals, so that many breads rely on cottonseed oil. And the bottom, rice. These are 4 major grains in the world that take up hundreds of millions of acres of the landscape. Corn alone in the United States is almost 80 million acres that is currently planted. Increasingly, in the United States, farm size is increasing, meaning that there are fewer and fewer farmers. And surprisingly, the diversity of crops that are planted on individual farms is also going down. So what that means is that farming is becoming more highly specialized, that farmers are knowledgeable about fewer crops. They have less capacity to manage problems such as pests, fungi, insects of different sorts, because they really don't have the fundamental understanding of ecology that many farmers had to have in order to survive in a world that was not as chemically dependent as ours is. Current industrialized agriculture could be successful on a parking lot if you brought in soil and you brought in fertilizer and you brought in water and artificially added organic matter. So basically, the more you control your environment using industrial technology, the more expensive it becomes. But the less you have to worry about understanding ecology. So it's curious that as centralization has occurred in ownership patterns, the farms got larger, the crop specialty diminished. Our dietary patterns have followed a similar pattern. We've relied on fewer and fewer crops, so now that most people's diet is comprised of between 30 to 40 different individual crops. So I want to talk today about what the central problems in food and agriculture are. And these include food availability, and I think most of us understand that the role of government has often been perceived as one of trying to make sure that we have a productive food supply, that our agriculture is as productive as it possibly could be, so we could maximize our exports to other countries so that our balance of trade would be helped, but also so we could deal with undernourished and impoverished parts of the world that did not have the capacity to grow food for whatever reason. Food prices are going up, particularly in the last decade. They've taken up an increasing percentage of the average household income, meaning that people are looking to buy lower cost foods, and lower cost foods are often higher calorie foods. They're often foods that come in bulk packages. So people are more prone to buy the liter and a half bottles of soda than they would individual cans. And that has had an influence on patterns of food consumption. As I mentioned, species dependence has gone down. We're relying on fewer and fewer crops. We're genetically engineering those crops more and more. A very high proportion of corn that's planted in the United States is now genetically engineered. The same goes for the other major grains that we produce. Also, a serious problem that we have is that our tastes are being cultivated by other organizations, particularly food processors that are adding ingredients that we don't really pay much attention to in terms of fat, in terms of salt, in terms of sugar, and a variety of artificial flavors and colors that they do very careful social surveys to understand what kinds of tastes, what kinds of colors, what kinds of flavors people enjoy the most. I use the example of the Salmo fan, so that salmon is now colored in 35 to 36 different shades, ranging from a really deep red to a very light coral. So they did their focus groups and conducted surveys and figured out that most people like number 33, so that type of thinking is pervading the food industry. We as buyers tend to respond. We respond by basically looking for the lower cost foods, but also those that seem to provide either taste or some other aesthetic appeal. We also are consuming more calories than we ever have before. We are consuming on average in the United States about 3,900 calories per person. Only 15 years ago we were consuming about 3,200 calories, and that's up from perhaps 2,800 calories per person. And the average person with the average weight, say a 165-pound male, could survive extremely well on a diet of about 2,400 calories per day. Now this would vary tremendously. I know some of you are athletes. Some of you may run 10 miles a day. Some of you may swim 4 or 5 miles a day. Those of you that exercise a great deal will obviously need a much higher caloric intake. But if you combine knowledge about what's happened to our behavior and our increasingly sedentary lifestyles, sitting behind computers, watching video games, the latest report came out only last week demonstrating that kids are now spending 7 hours a day looking at electronic equipment of one form or another. This is really quite striking. In my generation, we had televisions, but you know, television wasn't that big a thing when I grew up, and we spent a whole lot more time outdoors. People are spending time indoors. They're not burning up as much energy as they used to, so we're all putting on weight. Water consumption. Water consumption, especially in arid parts of the world, irrigation necessary for agriculture, this is a critical problem, particularly related to climate change, which is causing experts to predict that it's going to be increasingly expensive to move water into drier environments, meaning that it's going to be a requirement to ship those foods from longer distances, demanding higher energy. Most of us don't really have much knowledge of the energy it takes to produce, say, a bowl of peas as opposed to a bowl of oatmeal or a steak. And that's quite curious. The amount of energy that obviously increases with distance from the source of production to the source of consumption, but we really don't pay any attention to that, and we don't have any way of measuring it. This, by the way, would be a terrific term paper if somebody's still thinking about a research topic for the course. Just take one food. Just take apples. Figure out where apples are produced in the world. Figure out where Yale buys its apples, and try to come up with a metric for the energy involved in moving an apple from point of production to point of consumption. So, you could imagine a society decades into the future where you could take your iPhone and you could walk up to a grocery store shelf and you could hold the barcode on the food or on the side of the shelf next to your phone, and you could call up information on where the food came from. You could call up information on its energy. Was it produced using artificial chemicals? Or what kinds of fertilizers were used to produce it, so that we could get a whole new level of understanding of energy and the environmental health of different products, including issues such as protein content, fat content, type of fat, amount of salt, etc. Right now, most of us walk through the marketplace really blind to these issues, blind to the environmental effects of food production, blind also to the energy consumption. We also have very little understanding of food processing, and I want you to think about a couple of commodities that you experience on a routine basis. You take cotton, for example, that I just showed you a picture of. Cotton cotton seeds are put into a machine. They are ground up. Then they are sprayed by a solvent. The solvent extracts the oils, and the oil drips down into vats. It gets mixed with other kinds of vegetable oils and winds its way into supermarkets. How about grapes? Well, grapes have water extracted from them, and they are turned into raisins. You can think of a variety of different foods. Corn as another example. Oil is extracted from corn. How is it done? It's done using a solvent. Well, what happens to the solvent? Where does it go? Are there residues of the solvent in corn oil? And the answer is often yes. The residues do persist. They do get into the food supply, but we have very little understanding of what happens to food when it leaves the farm on its way to our dinner table. Food packaging is a topic that we'll take on in a few weeks, particularly with respect to plastics. And the absence of our understanding the origin of the plastic, the content of the plastic, the energy that it takes to produce the plastic is really quite striking. All of the plastic waste that surrounds most of the meats that are produced and available in grocery stores is thrown away. And there's almost no hope that any of that plastic is ever recycled. It's simply discarded and it's burned, and many of the plastics contain chemicals that you really don't want to breathe. Or if they're buried in landfills, they will leach. They will break down gradually, and they will leach into soils and underlying water supplies. And as I mentioned in an earlier lecture, in every landfill, among the 300,000 that exist in the nation, you can find these residues of plastic in the soil and the underlying groundwater supply. So the key environmental and health problems associated with our methods of food production include pesticides, and I'll talk a bit about pesticides today and the structure of pesticide law. There are now some 25,000 pesticides that are packaged in different ways and sold in different combinations in the United States alone. In the world marketplace, there are 75,000 different pesticide products that have been registered by different nations. How about fertilizers? Well, in some parts of the world, human waste is used as fertilizers, animal waste is used, but also there are fossil fuel-based fertilizers that are very common. So increasingly, we find fertilizer being used as farmers continually plant and replant the same field. They don't let it lie fallow. They don't plant crops that can fix nitrogen into the soil so that they have to add it artificially. Coloring agents, most of you probably do not pay too much attention to coloring agents in your food, but there's a very interesting history of coloring agents, and different nations have different laws, and some of these agents are natural, others are artificial, but that would be another great paper topic. Just take a look carefully at what we know about different kinds of chemicals that are used to color foods. Flavors also, artificial flavors and natural flavors, what do you know about them? They do not have to be labeled under federal food law, so natural flavors is an umbrella category. Artificial flavors also is, and this is a huge industry. If you decided you wanted to produce, say, a new concoction, maybe it would be a coconut-flavored applesauce, well, you could basically get some sort of pureed fruit of different sorts, maybe pear, maybe apple, maybe peaches, You could grind the pulp up, and by processing it, you'd likely lose all the flavor, so you'd have to figure out how to put the flavor back into it. Well, you could do that really easily. I encourage you to go online and take a look at the International Flavors and Fragrances Institute. And it will give you a list of firms, chemical companies all over the world that will allow you to say, yes, I want to make a coconut lime applesauce or a root beer flavored chewing gum. They will give you the chemical company's name, and they will provide you with the essences necessary to create the product. Also, you may not know, but fragrances are commonly used in food because fragrances will trigger the same nerve response in your mouth and in your mind that the flavors will trigger. So to create a sense that you're eating, say, root beer flavored oatmeal, they could simply use a drop of a fragrance to give you that impression. So packaging materials, processing effects, contamination of air, water, and food, and genetic modification, these are all critical, highly debated topics around the world, given the fact that many nations have different standards, whereas the marketplace, the global marketplace, clearly is moving commodities at a lightning pace across national boundaries, creating serious legal problems for firms that have to understand the difficult problem of having different regulations in different countries. And there are deeper problems here associated with the food supply, and they include really a fractured legal and regulatory responsibility, and I'll talk more about that in a few moments. Private science, the fact that the majority of science that underlies understanding the environmental effects, the health effects, the energy consumption required in order to produce and move food, the energy required to deal with the waste, that the science is being conducted in the private sector. It's often not available to the public sector. So trade secrecy law is quite important in this case, in that it often prevents you from understanding in detail what you'd really need to know in order to take control over your own diet. Worker safety is another deeper problem that we don't pay much attention to. If you look at the farm worker poisoning data, it becomes apparent that workers are often not well protected. They're often not monitored. They often do not have insurance and health care, so that it's a neglected population. Migrant workers traditionally have been exploited in almost every nation in the world, but even in our country, where we think we have highly sophisticated law, workers really are not protected nearly the same as you or I would be, so that there are different standards for allowable risk for workers than there are for you or I, say, from purchasing food in the marketplace. There's different contamination limits. Another deeper problem is the narrative advantage of the producers. If you look at the scale of the advertising industry and their methods of advertising, and this also would be a great topic for a paper, what are their dominant strategies? How do they make claims of product benefit? Either that it is natural, that it is healthful, how far can they go, and what laws restrict what they can claim? What about their requirements to disclose risks that are known to be associated with their foods? So it's interesting that the organic food industry evolved basically growing from a strategy that proclaims that a certain class of chemicals is not present in the food supply. So synthetic organic pesticides are not allowed to be used in organic foods. Now, that doesn't mean that those that are producing non-organic foods have to label what synthetic organic chemicals are in their food. So you can think about different legal strategies that might be employed in order to provide the consumer with knowledge that would be really necessary to understand what they're eating. Public subsidies also are a worthy topic for somebody interested in trying to transform the international food system. So if you look at the subsidies carefully, and you can do this now because there is a group in Washington called the Environmental Working Group that put together a terrific website. So you can go to the website and you can find your home state in your county or your town, and you can figure out which farmers are getting which subsidies. And what you'll see is that industrialized commodities such as corn and wheat and cotton, they're receiving the bulk of the subsidies in the nation. As opposed to the organic farmers or farmers that are beyond organic, who basically receive no subsidy. So that government funds could be used to innovate, to really transform the structure of agriculture in the nation, but this is not likely in the near future. Land values. How do land values play into the pattern of farming and agriculture that we currently see? Well, what I suggested earlier in the talk was that as urban areas and suburban areas sprawl out into undeveloped lands, they commonly will cause property values in lands that are nearby to increase. Their commercial value, their residential value, or their industrial value may shoot up quite quickly as a city expands, so that the value of the land in terms of its productivity for different crops often can't compete with this rising property value, so that the farmer sells out. Also, the agricultural land, it's flat generally. It also is not forested. And what this means is that it's really easy to develop. So you can imagine the problem of developing in a forested area. It's much more expensive for a land developer. So you find the rate of transformation of farmland from especially in rural parts of the U.S. That are in the target zone for urban expansion. These lands are being shifted into residential and commercial use at a very rapid rate. So the fundamental problem that I think we face right now is one of intelligence, and I don't mean to imply that it's an absence of capacity to understand these things. It's an absence of producing the knowledge and making it publicly accessible to consumers in a way that really could empower you to react in the marketplace in a way that would send messages back to corporations, messages that I think really are often much more powerful and often more listened to than messages sent by regulators. So I'd like you to think about corn and ethanol for just a moment, and the increasing subsidy for the production of ethanol that will oxygenate fuels and is required by different levels of government, including the Environmental Protection Agency, as a way of improving air quality. But what is increasingly apparent is that the ethanol subsidy has caused corn prices to rise quite dramatically because more of the farmers are putting these ethanol production plants on their property, and they're not shunning the corn into the food supply. Now, there also is an overabundance of enthusiasm among the farmers to produce the ethanol. So the ethanol market started to collapse, and this has hurt the farmers throughout the United States. Think now about one area, and the area of chemical application, particularly pesticides. This is an interesting area in that it demands that you think about a real variety of laws. The Federal Food, Drug, and Cosmetic Act on the top here, the Federal Insecticide, Fungicide, and Rodenticides Act, and the Food Quality Protection Act. These are the dominant statutes in the United States that apply to pesticide control. But other laws as well are necessary to understand and have some control over pesticides, including the Safe Drinking Water Act. In other words, one would need to worry about the application of billions of pounds of pesticides in the United States every year because pesticides often don't just go away. They often will move down through soils and into groundwater supplies. So we'll talk a bit later in the week about the problem of managing drinking water quality. By the way, the government in its food intake surveys concludes that the #1 food that everybody eats in the United States is water. Water is classified as a food under the Food, Drug, and Cosmetic Act, so that worrying about water contamination is a really important issue. And understanding the way that chemical release into the atmosphere as well as onto plants and into the landscape, that could contaminate drinking water, even if it goes through a filtration plant that often is the case for many urban areas. Resource Conservation and Recovery Act that we talked a bit about last week, and Superfund, most of these sites have pesticides within them, and they are classified as hazardous sites in part because of the pesticides that are there. Pesticides were in the RCRA sites and the CERCLA sites on Vieques. Predominantly chemicals that are persistent were applied back in the 30s, 40s, and 50s. The Toxic Substance Control Act does deal with pesticides. The Hazardous Material Transportation Act does as well. National Environmental Policy Act that we talked about last week. Endangered Species Act, if you have an endangered species and its habitat has been defined, it's normally illegal to apply pesticides in that habitat. The Wilderness Act would prevent pesticides from being applied within its boundaries. And the manufacture of pesticides often produces airborne residues that are regulated under the Clean Air Act, and also the release via pipes from those plants is regulated under the Clean Water Act. But as well, you can imagine the problem of spraying chemicals year after year on a landscape, and then you have rainstorms coming in the spring. Give you a good example of that, atrazine, which is an herbicide. It's a pre-emergent herbicide, so they plant the corn, but before the corn sprouts, they'll spray the landscape with the atrazine, often in the spring. Always in the spring, actually, and particularly in the Midwest. After the spring rains come, you can measure spikes in atrazine in the Mississippi River and most of the Midwestern rivers. And these rivers in the Midwest provide water supplies for tens of millions of people. And the filtration of the plants will not take it out. So both the Clean Water Act and the Safe Drinking Water Act come into play in that case. And the Occupational Safety and Health Act also is designed to protect worker safety, but as I said earlier, it often sets standards that are far above standards that are set for non-worker environments. So it's a very complicated body of law, but for this reason, pesticides becomes a good window to understand law. One way to think about this is that it's driven by two things, really. One is that pesticides are intentionally toxic substances. They're not like, say, just some new chemical that somebody designs, to be added to plastic to make it stronger. That wasn't designed to kill a different species. It was designed to provide some functionality. But pesticides as a group of chemicals were specifically designed to injure either a plant, an insect, some other species. In fact, some of the nerve gases that were designed during World War II and in the 1920s by Great Britain and Germany, Nazi Germany, they were designed specifically to harm humans. And many of these nerve gases have been diluted down for agricultural purposes, so that all species have been targets for the development of this class of biocides. So number one, they're intentionally toxic substances. And number two, to get their effect, they've got to be released to the environment in great quantities. So you release a chemical to the environment, the atomic weapons testing history tells us you better understand something about where it goes. And pesticide history is replete with examples where people paid too little attention. Now, I want to step back and take you into the earlier part of the century. And I want you to think about a very serious problem at that point in time and a problem that persists, and that's malaria. Malaria is an illness that's transmitted by a parasite. It's the Anopheles mosquito and all of its variants had the capacity to take the parasite up from the blood of an infected animal or an infected human. So if you had malaria and an insect came and landed on you, the Anopheles mosquito would first spit a little bit of an anticoagulant through its proboscis into your body to help you bleed a little bit, and then it would suck your blood into its stomach cavity, and with that blood, it would pull in malaria parasites that are in your body. Then perhaps assume I didn't have malaria, that mosquito flew over and landed on me, it would bite me, and when it would insert its anticoagulant in its saliva in me, it would transmit parasites into my body. And that's the way that this illness is transmitted from person to person. The parasite has the capacity to live for 9 to 11 days inside the body of a mosquito. And this is kind of an interesting issue, that the encephalitis virus lasts from 10 to 25 days. And thank God the AIDS virus lasts only 1 to 2 days. So that the longevity of different viruses or bacteria or parasites inside different insects affects the rate of transmission. So I want you to also understand the scale of this problem in the world. And today there are about between 300 and 500 million people that are clinically disabled by malaria, meaning that they're walking around with this parasite in their bodies that is sapping them of energy, that is giving them periodic fevers, that makes them more susceptible to other kinds of illnesses. And 40% of the world's population live in areas that are at risk, meaning that the mosquitoes in that area are capable of transmitting the parasite, and you've got a large population percentage that also is carrying the parasite in their bodies. The core of the problem for malaria in the world is really in tropical regions, and particularly in Africa, where 90% of the incidence and mortality exist. And the estimate right now by the World Health Organization is that roughly 1 to 1.5 million people die every year from malaria. And the estimate over the 20th century is about 100 million people have died from this illness. It's quite striking that many people have not understood the scale of this problem. So it's also clear, if you read much military history, that malaria was a very serious problem in all wars. So that if you go back to the time of Napoleon, or if you look at the history of World War I or World War II, as the U.S. or other countries moved into tropical parts of the world, more casualties commonly occurred, more lost days among GIs occurred due to malaria than it did to the direct effects of casualties. There are also susceptible populations, kids in endemic areas, although in epidemics all age groups are affected. Refugees and migrant populations and those living in tents, such as those that are fighting in armed conflict. It's all related to heightened exposure, being out in an environment where you're exposing yourself to being bitten by infected insects. So you could also imagine that those that work in mines, or those that work in forestry in tropical parts of the world, or agricultural workers, they are also more at risk. People that spend time outdoors in the tropics in endemic areas are more at risk, as are those with reduced immunity. Who has reduced immunity? Well, pregnant women. Pregnant women are extremely susceptible to very serious illness from pregnancy and also miscarriages. Also the very young children, those that already have their immune system compromised, or in parts of the poorest parts of the world, you often have the background high incidence of acute respiratory infections or diarrheal diseases that reduces strength and immunity and makes one more susceptible to this illness. Well, one of the ways of controlling malaria included pesticides. And here's an example of a worker in 1939 in an outbreak in Natal, Brazil, when a mosquito actually hitchhiked from Africa on a mail boat, an Anopheles gambiae mosquito, not indigenous to Brazil. So they finally figured out that it hitchhiked on this mail freighter, was able to or a number of them did, and they were able to establish a fairly large and robust population. It occurred during a rainy season when they had exactly the right pool of water standing on areas. Some mosquitoes actually are interesting in that they prefer streams or rivers that are moving really quickly as habitat. Others like very still water, others like shallow water, so that there are hundreds and hundreds of different species of mosquitoes capable of transmitting these illnesses, such as malaria or dengue fever, or yellow fever. so that understanding the ecology here is really important. One way of dealing with the problem and not understanding the ecology is basically to simply spray broad areas of the landscape with pesticides, which is what they did in this case. When U.S. troops invaded islands in the Pacific in the war against Japan in the mid-1940s, the incidence among U.S. GIs was often 3,000 per thousand per year, as it was reported, meaning that everybody on the island had, on average, malaria at least 3 times. So that the casualty rates here caused them to have to move troops in and out of the island much more rapidly than they normally would have. The development of the chlorine industry is a very important part of this story, because chlorine is a key component of many pesticides that were developed in the 1940s, including DDT. Chlorinated hydrocarbons include aldrin, dieldrin, heptachlor, chloridane, chemicals, curiously, that became the target of the Environmental Protection Agency as soon as it was formed in the 1970s. And why is that? Well, because all of the properties that made strontium-90 a dangerous compound, it persisted, it moved widely through the environment, it would contaminate virtually every compartment, and it would build up in food chains, marine food chains, as well as in ecosystems, in terrestrial ecosystems. It would get in people's bodies, and it would be transmitted via breast milk across generations. So a search was on during this explosion in the chemical industry in the 1940s for a variety of new chemicals that would replace the older metals, like Paris green. In the previous shot here, this gentleman is mixing Paris green, which is arsenic. He's mixing it by hand, and he's just basically just throwing it out across a stream. So that the heavy metals used earlier in the century were replaced by the chlorinated hydrocarbons, and gradually they figured out that DDT in particular was exceptionally effective at controlling the insects that would transmit the parasite that is malaria, that causes malaria. So this was first tried as refugees moved through Europe during World War II. And here's an example of taking basically a variant on a bicycle pump and taking a hose, and the drill that was followed was there was one shot down the back of the neck, there was one shot down the waistband, and then up into the lower part of the shirt, front and back, and then up both of the pant legs. So that tens of thousands of people were lined up in Rome walking through these stations as people that were sanitation workers then would basically man these pumps and spray people. This attempt brought the typhus epidemic that is transmitted by fleas to a close extremely rapidly within a matter of a couple weeks, when it was anticipated to go on for months, if not years. Another example of a child at the time being sprayed. So gradually, they recognized that DDT would kill so many different species that it was sprayed across marshlands and landscapes, and they realized at the end of World War II that they should also release it for agricultural purposes. So by 1950, DDT was being marketed as an effective way to control pests that would threaten just about every crop you could imagine. More than 300 different crops, critical components of U.S. agriculture, were recommended to be treated by this single chemical. So DDT is good for me. There's a little jingle that went along with this that kids would sing. There was no understanding of its bioaccumulation capacity, even though they understood that they only had to spray it once in an area, whereas other compounds they would have to kind of come back and keep on spraying. So I'll tell that story in just a moment. But here's another example of Jones Beach in New York, where the county public health department is driving down the beach, and the sign that is on the side of this truck, you can't read it, I'm sure, but it's telling, it says DDT, powerful insecticide, harmless to humans. Very little understanding of what they were doing. Kids were running down, people were eating their hamburgers, trucks would come by, kids would be sitting at picnic tables. The picnic table, all the food, and the kids included, would be sprayed. Very little understanding of kind of the basic ecology of this compound. So it persists in the soil. It was later discovered 10 to 35 years, and in the atmosphere for 3 years. And just as an aside, they decided that they were going to just test the air, just by chance. Somebody said, well, you know, this is a ridiculous thing to do, but 30 meters off the ocean on a freighter halfway between San Francisco and Tokyo, they took air measurements and found that DDT was present in the air in the middle of the Pacific Ocean, and that there was a latitudinal gradient. So that as you approach the equator, you would have a higher concentration of DDT than if you moved away. And why was that? Well, it's because of the increased number of pests that you get closer to the equator in tropical parts of the world led those nations to spray more DDT, both for sanitation, public health purposes, but also for crop protection purposes. It was also found in human tissues, and it probably is still detectable in your tissue. In fact, I was looking at the Food and Drug Administration's records on pesticide residues in the food supply. It's kind of striking in that even today, DDT is one of the most detected chemicals in the U.S. food supply, particularly in milk products, at very, very low levels. But it's a good indicator of the long-term persistence of this compound and why we need to pay attention to that. Also, like strontium, it was detected in breast milk. Meaning that if you were breastfed, your mom probably had a higher concentration than you do, but any body burden that you've got is coming from probably just stores from your mom, because this compound binds to body fat. It's lipophilic as opposed to hydrophilic, and that's the way that you'd be exposed. Your grandmother probably had residues far higher than your mother. But this kind of transgenerational effect is quite curious. In 1971, the effort to regulate it was really pioneered by Vermont. Vermont passed a law banning DDT use in the state, and they had formerly been spraying it on their forests to control for gypsy moths. That was followed in Wisconsin in 1970 by a ban, in New York in 1971 by a ban. And finally, actually, the British also decided that this was not a problem, that the support for agriculture and the control of public health was so important that it should be continued to be used. Whereas the Soviets found that it was worthy of a ban. They came out strongly in favor of a ban. Finally, in 1972, remember, EPA was created in 1969, and it actually physically came into being in 1970. In 1972, William Ruckelshaus, who was the former administrator of the Environmental Protection Agency, decided that they should move ahead because of the effects on wildlife, but also the cancer threat to humans, he felt was significant enough to justify its regulation. And I know you can't read this, but there's an interesting phrase, and this is on in the New York Times, that effective December 31st, 1972. In the meantime, he explained, growers of cotton, peanuts, soybeans, the three crops that account for almost the total domestic use of DDT, will get instructions in the handling of a substitute pesticide, methylparathion. The substitute is, can't really read, is non-toxic, but unlike DDT, it degrades quickly. So they're trading off a persistent chemical for one that degrades quite quickly, not really understanding what the long-term effect might be. Curiously, the companies that manufacture DDT said to themselves, well, you know, is there a way that we could modify the chemical structure of the compound and sell something that would be a minor variant? And they produced a compound known as dicafol that was only a little bit different. And lo and behold, in all the parts of the country where dicafol was sprayed, they found similar effects in wildlife, particularly among large raptors. So in the Southwest and in the South where cotton is grown, they found dicafol building up just the way DDT had. So it was lipophilic, it was bioaccumulative, and basically became equally worrisome to the Environmental Protection Agency. So they banned DDT in 72. They got around to recognizing that not only was dicafol having the same effects, but it also was contaminated by DDT at a level of about 15%. and that they needed to get that chemical out of the food supply and out of the environment as well. So it took until 1986 for them to actually move ahead with the regulation, and then to work its way out of production took until the early 1990s. So this is the ban that wasn't a ban. The ban that took effect in '72 that really was not effective until the early 1990s. Now, if you then jump ahead, fast forward to 1999, you'll see that EPA is getting around to studying methylparathion, the recommended substitute by William Ruckelshaus in 1972. He decided, in 1999, EPA decided this chemical is more dangerous than we thought. In fact, methylparathion is responsible for more farm worker deaths and poisoning than any other chemical in history. Not only is it far more acutely toxic than DDT, but it also persisted longer than they believed. So one of the concerns that we have today is, what are we going to do with respect to the persistence of malaria, but also its likely migration into parts of the world where it had been well controlled. And if you look at where malaria exists now, you'll see that malaria is a problem predominantly in the tropical parts of the world, also the poorest parts of the world. And you'll see that the expected range of malaria, of the different species of mosquitoes that carry it, it's widening. It's widening right now in response to changing climatic conditions. So the habitat is becoming more favorable for disease transmission. Now, the World Health Organization recognized this, and they called together a group of people that were expert in pesticides, and I worked on pesticides for maybe 15 years, and worked with a group of about 7 other people, some from African nations, to try to understand how to manage malaria, particularly in Africa. WHO had gone along with the bans of EPA and most other high-income nations in the world and had phased it out. It did not recommend the use of DDT in any part of the world as of the mid-1970s. But they wanted to reconsider this because it was so inexpensive, and it was so effective, in part because it was so persistent. They realized that if it was sprayed both indoors and outdoors, it would cause the insects to evolve resistant strains that would be harder and harder for them to manage. In fact, many mosquitoes have developed a resistance to DDT, so that if they sprayed it on a wall inside a house, the Anopheles mosquito would land on the wall, but it could sense it through its feet, and it would take off. And so it's a new behavioral response that prevented it from absorbing a lethal dose. So gradually, the World Health Organization became concerned about increasing incidence of malaria, particularly in Africa, and convened this group to try to figure out whether or not it made sense to get behind DDT and to use it again. And the next most effective pesticide cost 4 times the level of DDT, so this was a problem. And the aid agencies were not willing to pay this increased expense. So that WHO finally in 2006 gave DDT a clean bill of health, so to speak, even though this group of experts that convened in 2004, this group found that, well, using DDT is really not a good idea. You should use a less toxic chemical, one that is less persistent, that would be equally effective, even though it costs more. So it's a matter of finding the money in order to pay for the chemical that would protect human health and environmental quality. At the same time, it would deal with the malaria problem. So I'm at time, and I'm going to stop there, and we'll come back on Thursday and take a closer look at the variety of laws that apply to food safety in the nation. Thank you.